All right, so looking at an example in context with these steps. So example 7.2.1 is a hypothesis test for one proportion using the one proportion z-test. So a concern was raised in Australia that the percentage of deaths of Aboriginal prisoners was higher than the percent of deaths of non-Aboriginal prisoners, which was 0.27%. So a sample of 6 years of data were collected, and it was found out that 14,495 Aboriginal prisoners, 51 died. Do the data provide enough evidence to show that the proportion of deaths of Aboriginal prisoners is more than 0.27%? And it tells us to use a level of significance, so alpha, our new symbol, of 0.05. All right, so in this case, we were looking at a prisoner who either died or didn't die, so we're looking at qualitative data. So as we read this, be able to detect that the initial set of data that was collected was qualitative on each prisoner, which means that our random variable is going to be p hat and our parameter is p. So again, the parameter that we're interested in here is going to be the proportion or percentage of all Aboriginal prisoners who died, which makes the corresponding random variable that we're going to compute from the sample data is going to be the proportion of those in the sample. And our sample size here, so little n, was 14,495. So the proportion of 14,495 Aboriginal prisoners who die. All right, so that is our P for parameter for the acronym PHANTOMS. All right, the next letter in PHANTOMS is H, which stands for hypotheses. So we're going to set up the null and alternative hypotheses. Qualitative data, so our parameter is P. And they're interested in if that proportion is more than 0.27%. So our alternative hypothesis here is that P is greater than 0.27%, which means our null hypothesis is that P is equal to 0.27%. Now 0.27%, remember that percent sign literally means divided by 100. That's what the symbol stands for. So this is 0.27 divided by 100. And so if we compute that, we get 0.0027. Okay, so in place of 0.27%, we could also put the number 0.0027. That would be equivalent. And then we're going to test this hypothesis. It gave us the level of significance was 0.05. So remember, that is our cutoff between unusual and unusual events. So that's actually the cutoff we used in this last unit was 0.05. All right, our next letter in PHANTOMS is A, which stands for assumptions. So we need to check the assumptions for the test. Keep in mind that these will be on your cheat sheet, so you don't need to memorize them. Our first one for all the tests that we're going to do is we need to check that we have a simple random sample. So they did give us data from these 14,495 prisoners. However, the sample was not a random sample since it was data from just those 6 years. And it was a number for all the prisoners in those 6 years, but those 6 years were not picked at random. So unless there was something special or very different about those 6 years that were chosen, the sample is probably a representative sample, so we're going to just assume this assumption has been met. The second condition for qualitative data is that each object can only go into one of two categories. So in this case, our object was a prisoner, and either a prisoner dies or doesn't die. Okay, so we have just two categories. And then we're going to check the conditions to see if the normal distribution can be used instead of the binomial distribution. And so again, we've got several conditions that need to get checked there. So for this case, P was 0.0027 and N was 14,495. So if we check the condition N times P and make sure that that is at least 10, we're going to get 14,495 times 0.0027. And if we key punch that on the calculator, we get 39.1365, which is definitely greater than or equal to 10, so that condition is met. And if we compute n times 1 minus p, we're going to get 14,495 times 1 minus 0.0027. And again, if we key punch that on the calculator, we get 14,445.8635, which again is definitely at least 10. And then the population size cap n was not given, so we're just going to assume that cap n is big enough to be greater than or equal to 20 times our sample size. So the conditions are met that the sampling distribution of p hat can be well approximated by a normal curve, okay, which means, okay, so our fourth step here, phantoms, then the fourth letter here is n for name the test. So since those conditions were met, the conditions for the one proportion z-test were met. So again, 1 because we have one sample of data, proportion, we're dealing with qualitative data, z-scores for the normal curve, and test for hypothesis test. Okay.